This video is on normal distribution, also called the bell curve. And I know I say this every time, but I really do like this unit, and it's one of my favorites. So sometimes the distribution of data has a special shape. So for example, the purple graph has one peak, so the shape has one mode. We're going to describe the shape of each graph and suggest a context the graph could represent. So that first one, the purple one with the one mode and it's evenly distributed on both sides, could represent me trying to leave my house at 7:45 every morning. So am I going to leave at 7:45 every morning? Well, no, but I'm getting pretty close to that 7:45. So going to the left is the times that I'm leaving earlier, and going to the right is the times that I'm leaving late. On the right, we have the following pink graph, and this could represent your exams on a math test. So ideally, hopefully most of you guys are achieving higher than a 50%. So then the data is more to the right. So higher and closer to 100%. In the blue, this graph could represent the number of people attending a restaurant. So the rush times are around lunch and supper. And for the yellow graph, let's see. For some people, this might be them drinking coffee every day. So some people will loyally have 1 cup of coffee every single morning. So that would be that graph. So normal distribution is data that, when graphed as a histogram or a frequency polygon, results in an evenly symmetrical distribution about the mean, also called a normal curve or a bell curve. Here we have a picture of our bell curve. In the center here is our average, the mean, and every stanza, every section is a standard deviation away. So going to the right, we are 1 standard deviation away, plus 2 standard deviations away, and then plus 3 standard deviations away. To the left, same thing, we're just -1, -2, -3. Now the normal distribution has certain properties. 68% of the data are with 1 standard deviation of the mean. And we have to consider the percentage that's above and the percentage that's below. So if we cut 68% in half, we get 34 and 34. So 34% of the population lie within 1 standard deviation above the mean, and 34% of the population lie with or below 1 standard deviation. 95% of the data are within 2 standard deviations of the mean. So in order to get 13.5%, we take 95, we subtract that from 68, and we get 27%. Once again, cut that in half, there's that 13.5%. Finally, 99.7% of the data are within 3 standard deviations. So in this chunk between 2 and 3 standard deviations above, 2.35% of the population fall in, and 2.35% of the population fall in a 2 to 3 standard deviations below, and then 0.15 for before and after 3 standard deviations. This, by the way, is a chart that you will have to look back on, and a lot of our questions are going to fall with that. So that percentage is standard for everything. I won't make you remember it, I'll give it to you on assessments, but that is a standard for everything. So we have the speeds of 1,000 cars recorded by photo radar. If the data collected was normally distributed with a mean of 105 kilometers per hour and a standard deviation of 10, determine the percentage of cars traveling between 105 and 115 kilometers per hour. So we're going to draw a bell curve. They told us what the mean was, the average, and that's 105 kilometers. Now it says the standard deviation is 10 kilometers. So our next chunk over I need to add 10 kilometers onto 105. So that's 115. Same for the second standard deviation over, add another 10. I'm at 125 kilometers and 135 kilometers for my next chunk. Now the percentages stay the same. So 34% here, 13.5% here. Going back to my chart, we have 2.35, 0.15. So this is 2.35 and 0.15. Same goes for below. So I have 34% here, and 105 take away 10 is 95. 13.5% of the population fall in this category, which is 85 to 95 kilometers. And 2.35% of the population is traveling between 75 and 85. Anything going slower than 75, we have 0.15% of the population. I want to know the percentage of cars traveling between 105 and 115. So that is between here and here. So we have 34% of the population. Next question. We want to know the percentage of, oh sorry, that's the answer from the last one. So cool, we got it right. Next. The percentage of cars traveling less than 95 kilometers per hour. So I'm going to go back up to my chart. We're looking at less than 95%. So here is my 95% mark, and I want to know less than. We know that 50% of the population is going less than 105. So if I take 34%, this chunk here, because here this interval is not included, and subtract that from 50, I will get the percentage of vehicles that are going slower than 95 kilometers per hour. And we get 16%. So jumping back to that question, the percentage of cars traveling less than 95 kilometers, 16%. And there's our answer here. What are the number of cars traveling between 85 and 105 kilometers per hour? So jumping back up, 85 to 105. Actually, you know what? I'm going to even use this chart here because it's not marked up yet. So 85 to 105. I'm going to take those percentages in those categories and add them together. So 34 plus 13.5 gives me 47.5%. So I have 47.5% of cars traveling between 85 and 105, but it asks me for the number of vehicles. And this photo radar was collecting and recording results from 1,000 cars. So if I take my percentage, times it by 1,000, I'll get the number of cars. Okay. The other thing, if you want to do this in your calculator, you'll have to use the percent symbol. If you're going to do this without the percent symbol, you have to turn this percent back into a decimal. So by dividing it by 100, we turn it back into a decimal, which is the same as moving the decimal twice to the left. So we have 0.475 times it by 1,000. And that's 475 cars that are traveling between 85 and 105 kilometers per hour. All right. The speeds of 1,000 cars recorded by that photo radar, and we want to know the number of cars traveling between 115 and 125. Go back to your bell curve. Here's 115 to 125. 13.5% of the population fall within that range. So I'm going to take 13.5% and times it by 1,000. I'm going to get that percent back into its decimal form. And we get 135 cars are traveling between 115 and 125. So there's my answer. And then once you're done, you can go on to practice 4, questions 1, 2, 3, and 5.